RheEnergise has completed the main mechanical works at its demonstrator project at Cornwood, a few miles from Plymouth, in Devon, in the UK. The R&D demonstrator, a real-life test laboratory, is a key element in RheEnergise's path to the commercial deployment of its long-duration energy storage technology. The main mechanicals now installed at Cornwood include the main turbine, the pump, and the generators, together with all of the piping and valves, the power conversion system, the mixing system, the fluid management system, the flow control systems, and the hydraulics. The main civil engineering works, including the powerhouse, the upper and lower reservoirs, and the underground pipelines, were completed earlier this year. In this film, we're going to take a look inside the powerhouse, where a lot of the hard work has been taking place. We'll be guided by UK-based Stephen Crosier, CEO of RheEnergise, and by Canadian-based Valerie Lamenta, R&D engineer, who is on site in the UK.
Hello, welcome to our powerhouse. What you can see directly in front of us is our control panel for all the various systems which are part of the powerhouse. And then behind me we have the main room, directly below me the turbine, beyond that the pump. In the far corner we have the fluid management system, our master control valves which are behind this deck, and then opposite me here are our electrical panels, electrical intake and the variable speed drives, and then below me which is our hydraulic power pack to actuate the various bits of equipment within the powerhouse.
Hello, my name is Valerie Lamenta. I'm an R&D engineer here at RheEnergise. I've been involved in various parts of our LOGIS project and at our test facility in Montreal. Various R&D activities, testing, building, but more specifically here at Lotus, I've done a lot of work in the powerhouse, which, as we see now, mechanical installation is complete, and we've now moved on to the commissioning stage, which is very exciting. So we've done a lot of commissioning of various mechanical equipment, and we have now started commissioning our main control system as well. So we have our main turbine, which is a Francis 99 modeled turbine, where we have done prior to the project some CFD and some analysis to adapt it to our high density fluid. So this is our power generation line. So the fluid comes down from our upper reservoir, runs through our turbine, generates our power, and then goes into the lower reservoir. And then right next to it we have our main pumping line, and this is just basically pumping our fluid up the hill whenever we need to charge our system. And there is a line in the middle of these two, which is our main drainage line. So this is in the event of something happening, we are still able to de-energize, we say, our system without having to run through any of our turbo machinery. So what we see at the bottom of the powerhouse here is something that's quite unique actually to our demonstrator project, and it is what we called our fluid management system. And basically, because this is an R&D demonstrator project, we know we'll be doing, I would say, off-normal operation, and the fluid might end up being in the reservoir for a little bit longer than usual. So while our high-density fluid is in the reservoir, we want to have a way to monitor the fluid that's in there at various heights. We want to be able to measure various parameters such as pH, dissolved oxygen, conductivity, just evaluate the health of our fluid throughout this project. And the way we're doing that is with our fluid management system. So we have a specific part of it that's meant for sampling at different heights in the reservoir. And then we have a second line which is meant to be more of a reagitation line. So that one is grabbing fluid really from the bottom of the reservoir and recirculating it through the entirety of the reservoir.
Stay tuned for our latest news as we approach a very exciting milestone.